Today we are going to design a NAND gate in the Cadence system. So for this, we first go into new. We already made a library. Then we need to go to the CV. Here I have made a library name practice. Then just type NAND. I'm using here a two input NAND gate. Oh, okay. So replace I. Then we need to go the analog leave type here NMOS. So GPD can anti and go to the NMOS one way. Put here. Similarly, here it is a NAND gate. Then we will try PMOS. Placed here. Here. Now wire it. Nice. This will be a terminal A. This is input, and this will be the B. This is also input. The output is taken from here. Now for giving, press P. Choose the input signal. What we have to do? A, B, B. Press enter. Sorry. Now got mistake. Delete it. P. Select input. A, B, B. I, this is A. This is A. This is B. This is B. Again press P. Now we have to select output. Press by. Hide it. Place it. So it should be connected. It is NMOS, so the substrate should be connected to the ground. Press wire. This is also connected to ground. For ground, we need to go instance analog leave. Where is analog leave? Type GMD. Sorry, a small GMD. Here it is ground. Click here. You can paste here. In the for PMOS, the substrate should be at the VDD. This is connected to VDD. This is also connected to VDD. Here we will apply a voltage source VDC, which is of type of VDC analog lead. VDC, by pressing Q, you can change their details. So VDC DC voltage I am taking 1.2 volt. Press enter. It is changed to 1.2 volt. Another terminal should be connected to ground. O is connected to ground. Connect it. Here, delete the extra thing. So it is almost completed. Now check and save. There is no any error. If you want to check any error, please press G. There is nothing here. So now go to the launch. Type ADL. Check the stimuli. This one stimuli. Click here. A and B are the two inputs. So go to any pulse. Just like it's always settled. So enable You have to changes this according to yourself. Now apply. So here you can see it is bit on. Then press on or A, press enable. Go to the pulse. Just change it to delay time. No need to for the delay time. Pre-edit 20 and 10 for this one. You can check. This is also same. So we will put different pulse enable. Just change it 15 to almost 8, 7 pulse width. Apply. Both are getting on. Okay. Now go to this trans. Let's say we are running for the 20 nanosecond. Press the conservative. Okay. And this is the running button. Press on the run. Wait for few time. It completely run till 19.52 nanosecond. Now it is completed. I can say. Now go to the result. Direct plot. Inform. What we do is we first click on A. A is generated. Click on B. B is also generated. Click on Y. The output will be generated. Now see this one. Separate this. This is A is 1 here. Just on top here. A is 1 here. B is 1. If the both there is 1 1, the NAND get 1 into 1 0 per bar. So it will be 1 into 1 1. Then bar is given to the 0. Again, verify this one. 0 into 1 0 per bar 1. So it is correct. Check this one. It is 0. It is 0. 0 into 0 0. Then bar it give 1. So we can see that our cells are properly working. This is a NAND gate we have designed in Virtuoso. Yeah, thank you.